The skylines of our cities, the bridges we cross, and the very foundations of our world are being redesigned. But this revolution isn't happening with steel or concrete. It's happening inside the silent, complex calculations of artificial intelligence. A new collaborator has entered the architect's studio and the engineer's office, the AI co-designer. This isn't a story about robots taking over jobs. It's about a powerful partnership, a synergy that's unlocking new levels of efficiency, sustainability, and creativity in the way we build our world. AI is no longer a futuristic dream. It's a tool being used right now to reshape our infrastructure, one algorithm at a time. The AI co-designer isn't just about automation. It's a fundamental shift in the design process itself. Imagine an architect or an engineer setting the goals for a project, the desired strength, the budget, the materials to use, the need for natural light. The AI partner then explores not 10, not 100, but thousands, or even millions of design possibilities, each one optimized for those specific goals. This data-driven approach is leading to infrastructure that is stronger, greener, and more in tune with our needs. So, how did we get here? The rise of the AI co-designer is thanks to a convergence of several key technologies that have been developing for decades. First, and perhaps most importantly, is generative design. Think of it as computational evolution. You give the AI a set of rules and goals, and it evolves a multitude of design options to meet them. It often produces complex, organic-looking shapes that a human might never conceive of, but which are incredibly efficient. It's being used for everything from lightweight aircraft parts to entire building layouts. Next is Building Information Modeling, or BIM. Many in the construction industry are already familiar with BIM, which creates intelligent 3D models of buildings packed with data. AI supercharges these models, turning them from static blueprints into dynamic, predictive tools. I can scan a BIM model and instantly spot potential clashes, like plumbing pipes running through electrical conduits, long before construction begins, saving enormous amounts of time and money. Then we have digital twins. A digital twin is a virtual replica of a physical object, a system, or even an entire city. This isn't just a static 3D model. It's a living one, constantly updated with real-time data from sensors. A digital twin of a bridge can show engineers how it's coping with traffic and weather, while a digital twin of a city can simulate the impact of a new subway line on traffic flow before a single shovel breaks ground. And the engine driving all of this is machine learning and deep learning. These are the algorithms that are so good at spotting patterns and making predictions from huge datasets. They can analyze past projects to predict costs, use computer vision to monitor construction sites for safety, and power the generative design tools that create novel solutions. Let's look at how these technologies are being used in the real world, starting with architecture. In Toronto, the software company Autodesk used its own generative design tool to plan its new office. The design team fed the AI goals like which teams should be close to each other, maximizing views of the outdoors, and even accounting for individual work style preferences. The AI generated thousands of possible layouts, each scored against those goals. The result is a highly functional office space, custom-built for the people who use it. Look at the Shanghai Tower, one of the tallest buildings in the world. AI-powered algorithms were crucial in optimizing the tower's unique twisting shape. This design wasn't just for aesthetics. It was calculated to minimize the massive wind forces at that height, which led to huge savings in structural materials and cost. AI is also enabling wild innovations in materials. A project in New York called the Shanghai Tower was built from bricks made of agricultural waste and mushroom mycelium. Computational tools were used to optimize the tower's organic form for structural stability and to create a natural cooling effect. Best of all, once the installation was over, the entire structure was compostable. This shows a truly sustainable cradle-to-cradle approach to building. In the world of engineering, AI co-designers are creating structures that are stronger, more resilient, and use far less material. The most famous example is the MX3D Bridge in Amsterdam. It's the world's first 3D printed steel pedestrian bridge. Its complex, almost alien-like organic form is the result of generative design. The AI optimized the structure for maximum strength with minimum material, creating something lightweight yet incredibly robust. Robotic arms equipped with welding torches then printed the bridge, layer by layer, guided by the digital model. But it gets even smarter. The bridge is embedded with a network of sensors that collect data on strain, vibration, and even the number of people crossing it. This data feeds into a digital twin of the bridge, allowing engineers to monitor its health in real time and predict when maintenance will be needed. This is the future of resilient infrastructure. AI is also helping us prepare for a changing climate. By analyzing massive climate models and historical weather data, AI can help engineers design seawalls, buildings, and power grids that can better withstand hurricanes, floods, and earthquakes. Now let's scale up to the city level. Urban planners are using AI to tackle huge challenges like traffic congestion, housing shortages, and social equity. Sidewalk Lab's ambitious and admittedly controversial project for Toronto's waterfront gave us a glimpse of this future. The vision was a smart city built from the ground up, with a digital layer managing everything from self-driving vehicle routes to energy use and waste management. The project was eventually canceled over concerns about data privacy and corporate governance, but it ignited a global conversation about the role of technology in our cities, and the lessons learned are still shaping smart city initiatives today. Cities like Singapore and Helsinki are already putting these ideas into practice. Virtual Singapore is a highly detailed digital twin of the entire city-state. Planners use it to simulate everything from how a new skyscraper will cast shadows to how air pollution might spread through the city. In Helsinki, a digital twin is being used to optimize the public transport network and plan for a more sustainable future. This isn't just about efficiency, it's about equity. By analyzing data on access to parks, public transport, and jobs, AI can help planners identify and fix inequalities between neighborhoods. So what are the big picture benefits of this AI-human partnership? First, there's a huge boost in efficiency and productivity. AI automates tedious tasks, freeing up human designers to focus on creativity and strategy. Projects get done faster, with fewer errors and lower costs. Second is optimization. Generative design creates structures that perform better while using significantly less material. This is a massive win for both budgets and the environment. Third, it unlocks a new frontier for creativity. AI can generate solutions that humans would never dream of, breaking us out of conventional thinking and pushing the boundaries of what's possible. Fourth, AI is a powerful tool for sustainability. It can optimize buildings for energy efficiency, design cities that encourage walking and cycling, and analyze the entire life cycle of materials to make greener choices. Finally, it improves safety. On the construction site, AI can monitor for hazards. Over the long term, predictive maintenance using digital twins can prevent catastrophic failures of critical infrastructure, saving property and lives. Of course, this powerful technology also comes with serious challenges and ethical questions. AI models are trained on data, and if that data is biased, the AI's designs will be biased too. An AI trained on historical city data reflecting patterns of segregation could accidentally create designs that reinforce those divisions. Then there's the black box problem. With some complex AI, it can be hard to know exactly why it made a certain recommendation. So, if an AI-designed bridge fails, who is responsible? The architect? The software developer? This question of accountability is a huge legal and ethical hurdle we need to clear. The role of the human designer is also changing. The future isn't about being replaced, but about adapting. The focus is shifting from manual drafting to high-level strategic thinking, creative direction, and critically evaluating AI-generated options. There's a real risk of over-reliance on these tools, which could lead to a decline in critical thinking and a homogenization of design, where everything starts to look the same. And naturally, there are concerns about job security, intellectual property, and the need for new regulations to govern this technology responsibly. The future of our built world is not a battle of human versus machine. It is a story of symbiosis. I will not replace the architect's intuition or the engineer's judgment. It will amplify those human abilities. The AI co-designer is a tireless collaborator, exploring millions of options and providing data-driven insights. The human designer is the conductor, setting the vision, defining the values, and making the final critical decisions. This partnership promises a future where our infrastructure is not just more efficient, but more beautiful, more sustainable, and more equitable. It's a future where our cities are a testament not just to human ingenuity, but to a new form of collaborative intelligence. The dawn of the AI co-designer is the dawn of a new blueprint for our world.